Welcome to this video, and we're going to be looking at factoring using the concept of differences of two squares. So the difference of two squares, difference means subtraction. Whenever you see difference, it's subtraction. And what's a square? A perfect square is a number whose square root is a whole number. For example, let me give you some of the perfect squares we have. Maybe 1, let me change my color to blue. 1, the square root of 1 is 1. 4, square root of 4 is 2. 9, the square root of 9 is 3. These are squares, perfect squares. And then a squared, the square root of a squared is a to the 4th. The square root of a to the 4th is a to the 2nd. So remember, every time you're getting a square root of like a to the 100, if this is divisible by 2, you just get 100 divided by 2. So the square root of this will be x to the 50th. So you just divide this by 2. Okay, so we're going to be using this difference of two squares to factorize. So you have to first, 1, it has to be a difference, right? Subtraction. And then 2, the two values being subtracted have to be squares, a square number. So ask yourself, am I subtracting 2? Are they square numbers? All right. So whenever you have a difference of two squares, a squared minus b squared, you just get the square root, add the square root. So this will be a plus b into bracket, subtract the square root a minus b. That's all you have to do. Yeah. Let me give you an example. If you have c squared minus 100, is c squared and 100 squares? Tick. Are we seeing a minus in between them? Tick. So this qualifies as difference of two squares. So what's the square root of c squared? It's c. Good. And what's the square root of 100? It's 10. Good. So this is the same as adding the square roots. So c plus 10 into bracket c minus 10. And you're done. That's factoring. Okay. Let's look at another example. Let's go down here. Is this a difference? No. So don't even proceed with this concept because this is not a difference. So this is a prime. We can't get the square root of that, really. What about these two terms? 25x squared minus 49. Is there subtraction? Are those two numbers that are being subtracted square numbers? The square root of 25x squared is 5x. And the square root of 49 is 7. Okay, good. So we can apply the difference of two squares here. You just get the square roots, add them, so 5x plus 7, and then also get the square roots and subtract them, 5x minus 7. All right, so sometimes, right, we might have to apply the greatest common factor, yeah, and then get our difference of two squares. So we see all these are differences, but these 32 is not a square, right? 18 is not a square. However, 32 and 18 have common factors, right? And the greatest common factor here is 2. Right? So how? If you get 2 times 16, you get 32. And if you get 2 times 9, you get 18. So first factor out the greatest common factor. So 2 will be left with 16s squared minus 9u squared. Now you're having a difference of two squares. 16s squared has a square root of 4s. 9u squared has a square root of 3u. So you're in business. Difference of two squares. So don't forget these two. Very important. So it will be 2 into, you get square root, add them, 4s plus 3u, and then get the square root, subtract them, 4s minus 3u. There you go. So you factored this. But this was not straightforward. But looking at the coefficients, they had common factors. So start with the common factors. And then finally, whatever product you're left with, ask yourself, is it a difference of two squares? Let me give you another example. Looking at these not a differences, not a square, 20, not a square number. But looking at them, they have common factors. These coefficients have common factors, right? I can multiply 5 by 9 to get 49. And also here I can multiply 5 by 4 to get 20. And then I can take out 1q because 1q is common before you get to q3. So if you factor out 5, because you see 5 is common here. So 5q, right? Here you'll be left with 9. So 9q to the second minus 4, that's a difference of two squares because the square root of 9q to the second is 3q. And the square root of 4 is 2. So 5q into the square root, which is 3q plus 2 into 3q minus 2. All right. So you still have a difference here, but it's not a difference of two squares. So you just leave it. That's the simplest it can get to.